Hello, my name is Andrew Yui. This is our Chapter 1 uh, lecture, asynchronous for this class. And on this one, I highly recommend to use the study guide that's posted on Canvas. It's going to make this much easier. I'm going to call out for the first question from the study guide just to kind of show you how that works. But I'm not going to be so obvious about it after the first one. But I just want you to know, use the study guide with this, and I'm not going to make this plug every chapter just for this first one. But what you want to do is use that study guide, answer it as we go along, and then have that available for the quiz, because it's a 30-minute quiz. If you have that study guide completed, you should ace it. So the previous class did not take advantage of that. I don't know why, but I highly encourage you to do that. But today we're going to go over the importance of MIS. And the textbook starts off with these case studies. I normally don't use these. If I do want to use a case study, I'll call it out so you know to read it from the book. But the first one I like is from Falcon Security and an analyst named Jennifer who was pretty passive, didn't have abstract reasoning, systems thinking, collaboration, or experimentation skills. She kind of waited. She was like, I'm happy to do what you need me to do, just tell me what to do. Well, companies don't want that. Every job I've worked at, except for maybe Target when I was a cashier, even then they wanted some critical thinking. So the employers want someone who doesn't wait to be told what to do. At State Farm, there's a lot of automation that could happen, systems improvements, and I took the time to do that, and I was rewarded for that with promotions. At the Air Force, they don't want people who just follow orders. Even though it's the military, you think you just want people that follow orders. Well, no, you'll run into problems where you're going to have to come up with a solution on your own. So they reward people who can do that. People who are team workers who collaborate with others, who ask critical questions, who pull their own weight. I've ran into problems early in my career where I would think of really good questions during a meeting, but I would be afraid, like, oh, is this dumb? Should I not say it? And then somebody would ask the exact same question like 3 minutes later, and everyone would say, oh, that's a great question. We hadn't thought of that. And then I will kick myself for not having asked it. Don't do that. Don't be afraid. Ask dumb questions if you think they're dumb. And propose ideas even if you think they're nuts. Be creative and be ambitious. So the study questions that come out of this chapter, I'm not going to read these, but these are the 5 big ones that will come out of this lecture. And here is the first slide with a study guide answer. If you go all the way to number 82 on the study guide, normally these follow a sequential order. 82 and 81 is actually on the next slide as well. These two are out of order for some reason. But this is all about the digital revolution. And the question is, the conversion from analog to digital equipment is known as the digital revolution. So I'll get that out of the way. You can mark that off on your study guide and pay attention to what we're talking about. Technology is fundamentally changing business. We're in the information age, where production, distribution, control of information are primary economic drivers. Think about a company like Facebook, who's worth more than like oil companies. This is a company that Facebook doesn't really produce anything. It's just a platform for people to spew whatever meme or conspiracy theory or whatever their opinions are on whatever. It's just a platform for them to talk. But what they have is information on people, and that is worth a lot of money. They can sell that to marketing firms or other companies who use that information to drive their business model. So it's a huge deal. Information is king right now. Information is the new oil. It's gold. And then the digital revolution is moving from mechanical analog devices to digital devices. And an example of that would be small businesses, companies. A lot of times will have a server rack in the 90s or 80s, they'd have a server in the office. Well, now it's cloud computed. It's digital. It's still stored physically somewhere, but you don't notice it. You don't have to interact with it. It's all digital. It's in the cloud. So that would be an example of the digital revolution. Now, understanding the forces pushing the evolution of new digital devices. And we're going to talk about study guide question 81 here in a second. But so what are the forces doing this? Well, there's Bell's law, which is about every decade, a new class of computers establishes a new industry. And you think back to the first computers, what they were able to introduce, like in the 80s. I mean, computers have been around for longer than that. But say the 80s when it became significantly commercialized. Who used it? Well, stock brokers, banks would use computing systems. State Farm still has computing systems from the 80s that they use, that they rely on. That introduced new industries. Michael Bloomberg, the way Michael Bloomberg made his billions was he created a Bloomberg terminal that's still in use, and that began in the 80s. Then in the 90s, you have personal computers came out. Think of all the things that introduced. It allowed for music editing, music producers. Anybody could be a music producer. Well, not anybody. If you had $5,000, you could. So there's still some constraints, but it was more widely available. Video journalism, blogging, Usenet started, and then in the 2000s, blogging really took off. Social media kind of became introduced. That's a new industry. And then cell phones, that's new hardware and software. Think of everything cell phones have enabled, like Uber and Lyft and Grubhub, and taking social media and putting it on steroids. So these are big shifts that happen every 10 years or so. And like the question from the study guide, what is a reason that information technology has changed from a minor support function to a primary driver of profitability? Well, it's because technology fundamentally changes businesses. When I worked at State Farm, I would complain that the company was too conservative in changing to trends. I mean, that it wasn't me complaining about it. A lot of people had this complaint that companies like Progressive would do new things, like having a GPS tracker in your car. State Farm was kind of late to that game. It's kind of hard to make big changes at a big company like that. But new, we call them insurtechs, come in and they completely change how the game is played, and then large companies are playing catch up to that. So you need to stay ahead of that so you don't go extinct. Understand how the next digital evolution will affect business and take advantage of it, and understand what an industry does and how it will change. What an industry does and how does it will change. I don't know what Pearson is going for with that sentence, but think about a taxi cab company. I mean, you saw a cell phone come out. If you anticipated Lyft or Uber, if you got ahead of that and created that for yourself, I mean, maybe you could have survived this new age. I don't know. Computer price to performance ratio. So you look at price per million transistors, which is what shoots all the ones and zeros. You see it's very expensive, and then as technology has increased, and we'll look at some of the laws around this, it's just getting cheaper and cheaper, and expect that trend to continue. We have Metcalfe's law. This shows that the network value is equal to the square number of users connected to it. So the more users you have on a network, think about if you wanted to start a competitor for eBay, it would be hard to, because you don't have many users, and so you don't have many sellers to attract new users. But for each user and seller that you add, it gets more valuable, to the point where you've kind of got market dominance because it's hard for somebody to compete with that because you've got all the users. For Amazon, think of all the things Amazon is in. They've got users in all these industries. Um, they've got a lot of interconnected things that add value. Um, all the users of Google, every time someone adds a Google Drive, well, they're kind of sucked into the Google ecosystem. And then they have that person's information to use, and they've got and it provides a lot of value. Facebook, social media, every new user adds value because that's more data that they can sell. This is a big slide for the study guide, so pay attention. We got Moore's Law, Metcalfe's Law, Nielsen's Law, and Kreider's Law. So it kind of lays it out what each one of these laws are. I'm not going to go in depth here. I think I've got a slide out of order because we already did Metcalfe's Law. But I'm going to go into these laws in depth as we go through. But I do want to call out that Moore's Law is a number of transistors per square inch. That's going to be important to know. That's kind of what's driving these price decreases that we saw on that line graph above. A result of Moore's Law is that the price to performance ratio has fallen dramatically. And then for a business professional, what's true about this is that they need to be able to assess, evaluate, and apply emerging information technology to business. Because you're going to have, as these prices flatline, you're going to have opportunity to take advantage of it. An example could be, look at 4K TV prices. This kind of follows Moore's Law. It's not exactly a transistor technology, but you look at 4K TVs, they used to cost $2,000. I'm looking at them in Meijer for Black Friday deals for like $300 for a 60-inch 4K TV. It has just collapsed, and that could create an opportunity for a business that might use TV or ultra high def TV, something that they could not have done 2 years ago that they can now take advantage of. You have to be able to assess, evaluate, and apply emerging information technology to businesses. And then Metcalfe's Law, we talked about this. The value of the network is equal to the square number of users. That's important. Network connection speeds increase for high-end users, and storage density. Yeah, I said I wouldn't go in depth with these, but then I just did. But we'll talk more about these later. Price of storage capacity per gigabyte. This follows the transistor trend where it's approaching zero. So that's pretty nuts. If you're in the gaming industry and you saw people start using single solid-state hard drives, well, that could be a business opportunity for you. You can do more things with your computer game because people have better storage, faster storage. Okay, why it's the most important class you'll learn. That's a pretty lofty goal. I don't know if it's the most important class, but it's very important. Obviously, I'm teaching it, so I'm partial to it. But we're going to talk about how technology changes business, why executives find ways to use technology to create a sustainable advantage. This kind of solves itself. You won a sustainable competitive advantage, and you can use technology to facilitate that. Assess, evaluate, apply emerging tech to business. Hopefully, you'll get some of these concepts in this chapter and through this course. So technological change is accelerating. Today's highly successful businesses could be bankrupt because technology changed and they didn't. Does anybody remember Blockbuster? Great example. Huge revenues that filed for bankruptcy within 6 years of their highest revenue year. Because what was the technological change? Well, the internet speeds and and the ability to deliver a DVD over the internet. You don't need a physical DVD anymore. You could say taxi companies are next because Lyft and Uber. Um, there's a lot of examples with this. Insurance companies could be overtaken by insurtechs if they're not smart about this. So what does that impact to you? If you want to come out as an analyst, as a business analyst or tech analyst for a company, how can you get job security? Well, look at Moore's Law, Metcalfe's Law, and Kreider's Law. Um, Driving data processing, storage, comm cost to essentially zero. That means any routine skill will be outsourced to the lowest bidder. So if you want job security, don't do just routine skills. You need to be creative, and you need to do non-routine skills to make yourself not tradable. What skills will be marketable during your career? Well, because of this technology change, you want to have non-routine cognitive skills. What I mean by that is seeing creative opportunities to use data to support the business that you work for. So, example I have at Heartland Community College, we've been when I started there in 2019, and they use a lot of reports with data tables. Um, but I was able to merge geographic data. I ran a script in Python to associate a latitude longitude data to a student's address, and I was able to show with a heat map where students were enrolling from and what areas students were high performers from or what areas students needed more support from. And this just blew everybody's mind. Um, that is a non-routine cognitive skill that you can use to make yourself uh, valuable and marketable. If you can do that, you're not just using information technology as a routine thing. You're using it to create value for your company. So what are some of these marketable skills? Let's put academic terms around it. Abstract reasoning, systems thinking, collaboration, and ability to experiment. So as the cost of data processing, storage, and communication is essentially zero, any routine skill can and will be outsourced to the lowest bidder. So we want to develop these skills, like non-routine cognitive skills that have gained more market value. Um, so that's an impact of rapid technological change. And non-routine cognitive skills increase an individual's job security. Abstract reasoning is the ability to construct a model or representation. Systems thinking is modeling system components and show how they relate with one another. Like if you look at systems thinking, that's a whole philosophical college you could go to say, when I adjust one thing in this system, it has all these other impacts. And people who are really good at systems thinking can view almost anything as a system. Collaboration is developing ideas and plans with others, and ability to experiment, being creative, and trying new things with your available resources. And here are all the things that Jennifer was bad about those 4 categories. So abstract reasoning is the ability to make and manipulate models. We're going to learn how to use and construct abstract models in Chapter 1, Chapter 5, and Chapter 10. Systems thinking is the ability to model the components of a unit to connect the inputs and outputs among those components into a sensible whole that reflects the structure and dynamics of the phenomenon observed. An example of this would be if you worked at a car manufacturer and you were anticipating like a trade war with China, and you knew that steel costs were going to increase 30%. you would be able to think of all of the ramifications, or have an idea of all of the possible ripple effects that would have on union contracts, on sales promotions with dealerships, everything down the road. That's all part of a system. So how one thing changes, how that impacts other areas. Collaboration is the ability, the activity of two or more people working together to achieve a common goal, result, or work product. This is important because you have to work with other people, and if you could be the smartest person and not work well with people and get passed up for promotion. Like, I don't think I've ever been the smartest person at any job, but I work well with people, and that has helped me advance. It is a very important soft skill to have. Having the ability to experiment, make reasoned analysis of opportunities, and there's going to be these self-doubt questions that you get, like, I've never done this before, will it work, is it too weird, I don't know how to do it. You don't want to go to market with a crazy idea, but you can at least begin to flesh it out and consider it or try things. If you're scared of failure, it'll paralyze many great things. Think of how crazy some of the big inventions have, like the airplane. Like, that's a pretty crazy idea, but it was important. It was huge. But yeah, think of how crazy of an idea it would be to say you're going to let strangers ride with some other stranger just because they have a Lyft app. Well, it seems like dangerous and terrible, but it's huge. Why are these jobs in high demand? About 70% of college grads need additional training. 46% work in jobs that don't require a degree. But there's better success for students with courses related to information systems. Tradable job. So let's look at what the definition of a tradable job is. Not dependent on a particular location and can be offshore, outsourced. They can be outsourced overseas, is true about tradable jobs. Work at a call center. Well, hate to tell you this, but that can be outsourced. Computer programmer, that can be outsourced. If we look at this, growth of jobs by sector, the one that's off the charts is computer systems. That's huge, and that's projected to continue. I said previously that computer programming is tradable, but according to the Bureau of Labor Statistics, all good computer jobs have gone overseas. That is false. They do not say that. They don't demonstrate that. This is a BLS Occupational Outlook. Shows median pay is increasing and those jobs are growing in the United States. So these are business occupations. This is all information systems work. Computer information tech, business managers, that's part of information systems, and logistics, human resources, these are all part of a business system, and these jobs are growing. And the pay's good. So hopefully we're leaving Lincoln College and getting a good job. So the bottom line of this course, these jobs are important. We need to think about how we think about doing business. So you have marketable skills, you can learn abstraction, systems thinking, collaboration, and so you're aware of high-paying good jobs. This example, A is for Alphabet. Well, they're referring, of course, to the parent company of Google called Alphabet. Talks about their owners, Page and Brin, that have the overall strategy, but they don't do daily operations. I think Page and Brin are both actually gone from the company now, but overall, the internet has changed innovation, it changed our lives, and Google is a great example of that. The company has gone huge growth, and they're the dominant search engine, which led to them expanding into other industries. Um, but they've restructured, and they've, if you remember from the early 2010s, there'd be stories about Google's campus and how they would have like sushi bar and free massages and like nap pods and all this stuff. Well, there was a huge bureaucratic climate, and they've gone to kind of cut that down a little bit. Their company is more nimble, autonomous. Um, that's kind of the struggle that companies go through when they grow and get so big. It becomes hard to be creative and to be innovative, like we talked about in previous slides, when there is so much bureaucratic bloat, and they've noticed it and they've addressed it. Management information systems. What are the key elements? Management use, what information systems are, and strategies. Hey, Calvin! What's the goal of MIS? It's managing information systems to achieve business strategies. Really, our goal is to create an information system that meets needs and takes an active role in systems development. We need business professionals using their cognitive skills to understand business needs and requirements. This happened a lot when, before I learned how to use SQL to do my own data pulls, I would have to work with a data analyst to say, hey, I need this data. I need these 5 things. Well, when I got the data back, I found out it's incomplete. I need these other 3 things. And so I'd have to ask the data analyst to do another SQL pull. And that was a inefficient use of everybody's time. So I learned SQL to do the code myself, and that made for a better information system because I was cutting out a bottleneck in the process, and I was able to use my skills on the actuarial analyst side and my SQL skills that I had to learn to find out exactly what I was looking for, and it was more efficient and led to better outcomes. So we need business professionals who can use those cognitive skills to manipulate systems. 5 components of an information system. You've got hardware, software, data, procedures, and people. So this is hardware, computer. Software, the operating system that runs that computer. Data, the customer profile information that you're going to load on that computer via software. Procedures, how that data is structured, how it's inputted, how it's used. And then people, the people who do all this work and utilize all the knowledge. So it starts out here pretty concrete and repeatable, automatable, and then it becomes less so as you get farther away from the hardware and closer to people. Between IT and IS. You'll hear it used interchangeably a lot. I even use it interchangeably sometimes. But information technology is products, methods, inventions, and standards, PMIS, and it drives development of new information systems. An information system is made up of the technology, the IT, how it's done, the procedures, and the people that make it up. All of that combined is information systems. Just use IT and IS interchangeably because IT does not encompass all the procedures or all the people. And information technology refers to the products, methods, inventions, and standards that are used to produce information. This is the PMIS, and that is on the PMIS, that is on the study guide. Systems are a group of components that produce information. Group of components that produce info. Business professionals need to be able to ensure the system meets needs, understands how information systems are built, consider user needs, learn how to use it themselves, and remember ancillary requirements like security. If you forget about security or how to back it up, maintenance of the system that can be a disaster. Something that we run into a lot at State Farm and at Heartland. We would build a system and forget that we built this little silo of information, and we built other silos, and we would have to remember to update all of them because we didn't build it intelligently. So you would end up with these sources of information that said different things if we didn't update them all at the same time. You have to really map that out and figure out how to remedy that, because that can be disastrous. Achieving strategies. Information systems should be created by a business only if they help achieve strategies of the business. That is absolutely true. You don't want to create something that doesn't advance some strategy of the business. So ask yourself, if you're building a Facebook page, what's the purpose of it? What does it do for us? What are we going to allow employees to do with it? How much freedom are they going to have to talk on it? Do all of these things reinforce our strategy or work against it? Or do they have nothing to do with our strategy? If they have nothing to do with the business strategy, don't do it. The last section we talk about, password etiquette. And it's important because security systems depend on the behavior of their users. So you can have the best security system, but if your users mess it up, then it's a disaster. Something that happened at Heartland Community College is there's a data hack because someone gave up a password and it caused a month of downtime for the college. So, not good. They have a good security system, but the users made a mistake. Let's look at password and password etiquette. You want 10 plus characters. Doesn't contain your username, real name, or company name. Does not contain a complete dictionary word in any language. Different from previous passwords. Contains upper and lowercase letters. Now this is actually different. I think your book says 12 plus characters. This says 10 plus. There are some differences between the book and this presentation. I'll call that out when I see them. You never write down your password. Never ask somebody for their password. Never give your password to somebody. Do-si-do. Move away so any other person can enter a password privately. That's common professional practice. If you have to go, what this means is if someone if someone calls you over to help them with something and they're locked out of their computer, don't look at their keyboard while they're typing their password in. Look away, because it's super weird if you just stare at them doing stuff. And let's see here. So, some things that you'll want to know. A password should not contain the username or company name. A drawback of a password that meets all the criteria for a strong one is that it can be difficult to remember, so that causes downtime. It causes spin where they have to get it reset and they'll be tempted to write it down. A password is weak if it contains a complete dictionary word. So any password with a full dictionary word in it could be a weak one. A strong one would not have a word, would not have a sequence of numbers, would have special characters. That would be a strong password. It's going to help you in your career. 4 key skills to use. IS components, have knowledge of that. Understand how everything plays a part in an information system. And realizing the future belongs to those who creatively envision new applications of information systems and technology. Kind of cheesy, but it's true. I mean, that is the future. Now you'll notice there are some ethics and responsibility guides. These are important. We're going to get into these more with different chapters, but not for this first one. Just want to keep this simple. But that is our Chapter 1 lecture.